Hello students, so today we'll proceed with permutation and combination. In last lecture we talked about the factorial notation, so we'll proceed with that only. In that I mentioned a property that you need to know. Hope you guys remember that property, that 2n factorial will be equals to 2 raised to the power n into n factorial into 1, 3, 5, 2n minus 1. Okay, so this was the case. 2n factorial will be equals to 2 raised to the power n into n factorial into 1, 3, 5 till 2n minus 1. And from here we can see this is 2 raised to the power n, means this is an even number, and 1 into 3 into 5 product of all odd numbers will also be a odd number. Okay, so this is an even number, this is an odd number. So now today we'll see what are the applications of this, and in mathematics what are the different applications of this identity. We can say it as identity, or we can say it is just a expression that we have discovered and we will use it, see its applications. Okay, so now question is, if 100 factorial is equals to 2 raised to the power m into I, if 100 factorial is equals to 2 raised to the power m into I, where I is an odd integer, where I is an odd integer, find the value of m. Okay, so the question is, if 100 factorial is equals to 2 raised to the power m into I, where I is an odd integer, find the value of m. Okay, so we'll use this concept that we have noted over here in order to find out the value of m. Now 100 factorial could be written as 2 into 50 and its factorial. 100 factorial could be written as 2 into 50 and its factorial, and according to this now n becomes 50, hence it will be equals to 2 raised to the power 50 into 50 factorial into 1, 3, 5, and it will be equals to 2n minus 1, means 50 into 2, 100 minus 1 till 99. Okay, now if we see, this will be odd number, this product will be resulting into an odd number, and here it is 2 raised to the power 50. Now what we need to see, we need to see what is this 50 factorial actually. Okay, so we'll expand this 50 factorial as, this is 2 into 25 and its factorial. So by the same concept, this will be equals to 2 raised to the power 25 into 25 factorial into 1, 3, 5 till it will be 49. Now again this is an odd, and you need to see here this, that this whole thing is included in this, means 100 factorial includes this thing, or we can say this product of 2 raised to the power 25, 25 factorial and this odd number, this is the part of 100 factorial. So means these 2 raised to the power 50 and 2 raised to the power 25, they occur in 100 factorial, means till now to have 50 plus 25 and 75 2's in the 100 factorial. So now again 25 factorial could be written as 25 into 24 factorial. Because it's an odd number, so we will not be able to apply that thing that we have learned over here. So what we will do, we will change it into some factorial of even number. So 25 factorial is equals to 25 into 24 factorial. Now this 25 will be again combined with the odd number, so that will not matter to us. We will focus on what is 24 factorial. Now this is 2 into 12 factorial. Now what is 2 into 12 factorial? That is 2 raised to the power 12 into 12 factorial into 1, 3, 5 till it will be 23. Okay, so same 2 raised to the another 12 2's are added in our product. Now we'll see what is 12 factorial. 12 factorial is 2 into 6 factorial, that means 2 raised to the power 6 into 6 factorial, 1, 3, 5 till 11, and similarly 6 factorial will be equals to 2 into 3 factorial, means 2 raised to the power 3 into 3 factorial into 1, 3, 5, hence 3 factorial is equals to 3 into 2. okay, or we can write it over here 3 into 2. Okay, now we'll see how many 2's we have found. The thing that we need to see here is this 3 factorial is part of this 6 factorial, 6 factorial is part of 12 factorial, 12 factorial is part of 24 factorial, 24 factorial is part of 25 factorial, and this 25 factorial part is a part of 50 factorial, and all these are part of 100 factorial. Means these many 2's are included in 100 factorial. So in total how many 2's are added? If bases are because they are in multiplication, and we know when bases are same the powers will be added, hence number of 2's, or we can say m is equals to, this is 50 plus 25 plus 12 plus 6 plus 3 plus 1. So this will be equals to 75, 75 plus 10 will be 85, 85 plus 10 that will be 95, 95 plus 2 that will be equals to 97. Okay, hence 100 factorial includes 97 2's in that product. Means it will be 100 factorial will be equals to 2 raised to the power 97 into I. Means I is a odd in number over. Okay, so this is how we need to calculate the number of 2's in any factorial. This could be the question also, or this could be asked as an application also, that how many 2's are there in 100 factorial. Okay, but if this question is there in the competition, so it's a quite lengthy process to find out the number of 2's in 100 factorial, or number of 2's in any factorial of any term. Okay, so we'll learn a shortcut how to calculate it in a second. It will just take a minute to calculate the number of 2's in 100 factorial. For that we need to recall the greatest integer function. Greatest integer function, if you remember, greatest integer function is 3.5, greatest integer will be equals to 3, means greatest integer less than or equals to that number. Okay, so I hope this is enough to get you to the greatest integer knowledge, that 3.5 factorial will be equals to 3. This and for further you can look for the greatest integer function discussion in function chapter also. Okay, so what we'll do now, we have to find the number of 2's in 100 factorial. So what we will do, divide 100 by 2 and take its greatest integer. What we need to do, divide 100 by 2 and take its greatest integer. So 100 by 2 is 50, and greatest integer of 50 will be equals to 50 only. Okay, divide 50 by 2 and take its greatest integer, hence it will be 25. Divide 25 by 2 and take its greatest integer, so it will be 12.5, and its greatest integer, so that will be equals to 12. Take 12 by 2 and its greatest integer, hence it will be 6. Take 6 by 2 and its greatest integer, hence it will be 3. Take 3 by 2 and its greatest integer, that will be 1.5, and its greatest integer, that will be equals to 1. Now simply add these values and the result will be the number of 2's present in 100 factorial. So that will be 50 plus 25 plus 12 plus 6 plus 3 plus 1, that will be equals to 97. So the result is going to be same every time. The number of 2's in that result will be in 100 factorial will be 97. If you see 50, 25, 12, 6, 3 and 1, these are the same values that we got over here, 50, 25, 12, 6, 3 and 1. Okay, so this is just the shortcut to find out the number of 2's in any factorial. Okay, let us suppose we are having any number 33. If I say how many 2's will be there in 33 factorial, how many number of 2's will be there in 33 factorial, what we need to do, divide 33 by 2 and its greatest integer, What will be 33 by 2? That will be 16.5 and its greatest integer, hence it will be 16. 16 by 2 and its greatest integer, that will be 8. 8 by 2 and its greatest integer, it will be 4. 4 by 2 and its greatest integer, that will be 2. And 2 by 2 and its greatest integer, that will be 1. So 16 plus 8 plus 2 plus 1, it will be equals to 16 plus 8 will be 24 plus 2, that will be 26, and 1, that will be 27. Sorry, 4 is also there. So 16 plus 8, that will be 24, 28, 30 and 31. Means in expansion of 33 factorial, there will be 31 2's present in that expansion. Okay, so this is the way to find out how many number of 2's are present in factorial of any number. You can be asked about 200 factorial also, you could be asked about 100 factorial also, you could be asked about 1000 factorial also. So this is the simple way to calculate how many number of 2's are going to be there. Okay, so now I'll proceed with the question. Will say it like find the exponent of 2 in this expansion. So exponent of 2 means how many number of 2's are there in that. Okay, find exponent of 3 in 100 factorial. Find exponent of 3 in 100 factorial means how many number of 3's are going to be there in 100 factorial. So for any prime number, the concept is going to be same. For finding out the number exponent of 2, we were dividing number every time by 2. Now we have to find the exponent of 3. We'll divide every number by 3. Okay, so 100 upon 3 and its factorial, that will be equals to 33.33. 33.33 and its greatest integer, so it is going to be 33. So 33 by 2 and its 3 and its greatest integer, that will be 11, and its greatest integer will be 11 only. 11 by 3 and its greatest integer, that will be equals to 3 point something, so its greatest integer will be 3, and again 3 upon 3 and its greatest integer will be 1. Okay, so 33 plus 11 plus 3 plus 1 will be our answer. 44, 44 plus 3, 47 plus 1, 48. Means 48 3's are present in 100 factorial. Okay, for any prime number, this is going to be the concept. If they ask about how many number of 7 are present, we will simply divide the number by 7. How many number of 11's are present, so we will divide the number by 11 in that case. Okay, what if it is not a prime number, but instead it's a composite number? Composite number means it's a combination of other two prime numbers. So what we have to do in that case? So we'll look with an example. Find exponent of 80 in 180 factorial. Find the exponent of 80 in 180 factorial. For this, just listen carefully. If the question is including having some composite number, what we need to do? First, we need to make the prime factors of that composite number. Means we'll divide 80 by 2, 40, 20, 10 and 5. Hence 80 is equals to 2 raised to the power 4 into 5. Okay, hence it is equals to 2 raised to the power 4 into 5. Means there are two prime factors. Now we'll calculate how many number of 2's are present in 180 factorial and how many number of 5's are present in 180 factorial. Okay, so we'll move step by step, then you will be able to get that what is the use of calculating number of 2's and number of 5's. So 180 upon 2 will be, and its greatest integer will be 90. 90 upon 2 and its greatest integer will be 45. 45 upon 2 and its greatest integer will be 22. 22 upon 2 and its greatest integer will be 11. 11 upon 2 and its greatest integer will be 5. 5 upon 2 and its greatest integer will be 2. and 2 upon 2 and its greatest integer will be 1. So means 90 plus 45 plus 22 plus 11 plus 5 plus 2 plus 1 number of 2's are present. And how many of the total be? They are total 176. Okay, they are total 176. Now let's see what is the use of this 176 number of 2's. Okay, now basic foundation of 80 is 2 raised to the power 4. If 2 raised to the power 4 is termed as alpha, how many alphas are present in 80? Okay, how many alphas are present in 180 factorial? So what we'll do, we'll divide it by 2 raised to the power 4. Means 11, or we can say this will be, the way to write that could be, simply leave it over here, that 176 2's are present. Okay, and same will calculate for the 5 also. The exponent of 5 will be 180 upon 5 and its greatest integer, it will be 36. 36 upon 5 and its greatest integer, that will be 7. 7 upon 5 and its greatest integer, that will be 1. So how many total will be there? There will be 44. Okay, means hence 180 factorial could be written as 2 raised to the power 176 into 5 raised to the power 44 into some other factors. Those are not of our use. Okay, this will be the case because we have calculated the number of 2's here, we have calculated the number of 5's here, and 180 factorial is going to be a big number, so there will be some other factors also. Those we have not considered because they are of no use to us. Okay, so simply we have talked about 2 raised to the power 1, 2's and 5's. What I'll do, 2 raised to the power 4 into 44 into 5 raised to the power 44 into some other factors. We can write it like this because 44 into 4 is 176, so I will written it to like this. So means 2 raised to the power 4 into 5 raised to the power 44 into I, means 80 raised to the power 44 into I. Hence we are able to find out the how many number of 80's are present in 180 factorial. Okay, so what we have done, we have just broken down the number 80 into its prime factors. They came out to be 2 and 5. We calculated the number of 2's in 180 factorial, we calculated the number of 5's in 180 factorial. Then simply what we did, we have written 180 factorial as 2 raised to the power 176 and 5 raised to the power 44 into some other factors. Now this 176 could be written as 2 raised to the power 4 into 44. Means this is repeated 44 times and 5 raised to the power 44. This combined gives me 80 raised to the power 44 into I. So means exponent of 80 is 44 over there. Okay, so this is how to calculate the exponent of any composite number. Prime number, for prime number it is simple, simply start dividing by that number and find the greatest integer. But in case of a composite number, what we'll have to do, we'll have to break that into some prime factors and then we'll proceed with that. Okay, so next we'll do another example for this. Find the number of zeros. Find number of zeros at end of 100 factorial. Find the number of zeros at the end of 100 factorial. Okay, so this is an interesting question. Actually, what makes zeros at the end of any number? Means how many tens are there in their product? Actually that is going to decide, because 10 into 10 they will be giving 200 zeros, and because it's going to give 100. 10 into 10 into 10, that is going to give us 1000, so there will be 3 zeros. So means the number of zeros at the end of any number are decided by number of tens present in that product. For example, it is 275,000. So means it is 275 into 10 into 10 into 10. Means number of tens are going to decide how many number of zeros are there at the end of any number. So in this example, what we'll do, we'll calculate the number of tens those are present. Okay, so 10 is surely it's a composite number and it is equals to 5 into 2. So what we'll do, we'll calculate the number of 5s, we'll calculate the number of 2s. Means we know exponent of 2 is in 100 factorial is 97. We know exponent of 5 is, if we have not calculated, you can calculate exponent of 5 will be coming out to be 24. That will be 24. So 100 factorial will be equals to, that will be 2 raised to the power 97, 5 raised to the power 24 into some other number that we are not interested in. Simply they are some random numbers, they have a random product, but we are not interested in those things. So it will be 2 raised to the power 24 into 5 raised to the power 24 into 2, rest 2 those are there apart from 24, means there will be 73 2's will be there. Now what this is going to be, this is going to be 10 raised to the power 24 into some other numbers. This is the case 10, because this is of no use to us, because we have to make 10 and they'll be making 10. These extra 2's, they are not going to play any part. So how many 2's are there at that? 24. Hence how many number of zeros will be there at the end of 100 factorial? There will be 24 zeros. So how many number of zeros will be there? There will be 24 zeros. Okay, so this is the way to calculate the number of zeros. Just what is the importance of this question? Directly giving, instead of directly giving what is the exponent of 10, they have given it like how many number of zeros are present at the end. Okay, so these are the type of questions, those are there based on the factorial notation. Next lecture will be based on the permutations, how to calculate the number of permutations.